Hi everyone, and happy holidays. Since it's the beginning of the month, December 2nd, I wanted to introduce to you what osmosis is. Osmosis is when a molecule of a solvent passes through a semi-permeable membrane from a low concentration solution to a high concentration solution where the concentration of the solution of equal size becomes equilibrium. Where we're going to start on our experiment is, so we're going to have three solutions. One is going to be with the ingredients that we are going to need is salt, basic distilled vinegar, and just your regular water, H2O. We're also going to use our teddy bear, and these are going to represent the semi-permeable membranes that we're going to use for our experiment to see how osmosis passes through from low concentration to high concentration. I'm only using these cups for the purpose of this video so you guys can see the observation. But normally I like to use these regular plastic red cups. We have our measuring cups here and the tablespoons, my ruler so we can measure from the beginning of prior putting the gummy worms into our solution, and I have a pen and I have posted tags to keep us organized as to which solution is which, and that is what we have for now. And I have my phone so that I can put an alarm on to check on our observation. So let's get started. I'm going to be measuring the gummy bears, so we're going to go with centimeters because it's going to be easier. What we're going to do, the reason why we're measuring these gummy bears is just to see how the changes in it. So like for this example, the gummy bear for lengthwise is going vertically this way, so it's about 2 centimeters. So let's write that down. So length, we're just going to go like this, equals 2 centimeters. Because we're going to use that for our calculations. And then we're going to measure the width, which is just pretty much going on our horizontal way, which is the width. And that is exactly 1 centimeter. So our width. And then let's see if we want to measure the density. So we're gonna measure the thickness of the gummy bear, and that's about 1 centimeter as well. I'm only gonna measure 1 only because gummy bears are usually manufactured in a mold, so each molds are already at equal parts, and the measurements are exactly the same. So 1 will suffice in this experiment. So let's get started. So the first thing I'm going to do is label my Post-it so I don't get confused as to which solution I'm going to submerge these my gummy bears in. So the first one, let's do water. I'm gonna label this as water, and I'm only gonna pour off, so this is my water. I'm only gonna pour off a 1/2 cup, which should be exactly right here. So if I measure that, you can all see that it's only a 1/2 cup, right? So we're gonna go ahead and pour that in. I'm gonna drop my gummy bear in. So my first part of this experiment is complete. I'm gonna set this aside here. Let's do the second part of the experiment. Second part of the experiment, I'm gonna label number 2, which is gonna be salt water. So just like before, I'm only gonna measure a half a cup of salt water for my salt water solution, I should say. I'm gonna label it number 2. I'm gonna pour into that, and then I'm gonna add 4 tablespoons. Let me put this aside so I have a better view. And this is only a tablespoon. As you can see, it's only a tablespoon. So I'm gonna do that 4 times. I already did it once, so I have 3 more to go. So this is the second, third, and last one. And you just want to mix it. And I'm just mixing mine with my tablespoon that I've used as I was measuring it. So it looks kind of murky, but that's okay. Whatever doesn't dissolve will sit in the bottom. And then we'll just submerge our second teddy bear in there. Gummy bear. So the third solution we're gonna use will be our vinegar. I'm just labeling this so you don't get confused which one is which. And just like so, I'm gonna pour in only a half a cup of vinegar into this solution. And then I'm gonna drop in my gummy bear, just like so. So our first observation is gonna be just water and our gummy bear. We will test this the following day, which I'm gonna put, the time is 5:49. So for tomorrow, December 3rd, I'm gonna put it for 5:49 so that I can check back again for it to see what it is. But in the meantime, let's think about what is gonna happen before we actually see a change in our gummy bear. So water is a wonderful solvent. Water will have a tendency to expand and increase the size of our gummy bear. So we'll see that if that's actually what's going to happen. In contrast, our salt water will be hypotonic, which means that it'll have a tendency to shrink our gummy bear because it will draw out all the water that is coming from the gummy bear. And I am not sure what exactly is this floating on top. Oh, sorry. What it is just a little paper that is on there, so that looks better. I just took that out and put that in there. So let's see if that is what our observation may be for tomorrow. And our third solution for vinegar, we might see 2 observations that will come out of vinegar. One, since vinegar behaves like water, it'll also increase just a little bit of the size of our vinegar because it's like water. However, it will also it'll break down, since it's an acid, it'll break down our gummy bear. So let's see if it becomes deformed or slimy or any of those sorts for the following day. But in the meantime, let's just set these aside and let's work on our calculations. So usually you can do two things with the calculations for graphing. If we wanted to measure all of this, the thickness, the width, so we can just multiply it across, okay? So that's what we're gonna do. So we're gonna go 2 times, this is L, represented by length. This is our width. And this is the thickness. I'm just gonna put T. And that's just when we're looking for density, okay? So that's just gonna equal 2. Same thing if we wanted to look for the area of our gummy bear. We're just gonna use length times width. And I should have used that time too, I'm sorry. So that our length was 2 times our width, that was 1. So that's gonna give us pretty much the same answer. So this is just my scratch paper. So this is actually the observation paperwork you would fill in. So for our first day, our centimeter for our length was 2, and then our width was 1. It's gonna be 2 and 1 as well, because they're about the same, 2 and 1. And that's just gonna give us the area of some curve, which is only 2 for the area, which I did a little extra just for the density part. So that's what the D stands for. And I should have wrote it density. Sorry about that. Let's just set this aside and we'll wait for tomorrow to see how it is for our samples. Hey guys, so this was our solution from yesterday. Let me just fish out our example. For our first solution, it was water. So let's see how big I'm gonna put it on here so you guys can see it. Oops, that was my fault. I kind of broke him apart. That was water. This is how big water is. When you submerge it into it, our gummy bear becomes very huge. And let's just see how big the size is now. So we originally started out with 2 centimeters, correct? And now looks like it's 3 centimeter, about 3.5, I would say, for the length. So I'm just gonna write it down here. For water. Oops, sorry, it actually has this for day 2, so we're just gonna put 3.5 centimeters. And then let's measure the length. Look how jelly it is. It's like, the reason why it's jelly-like texture is because of the glycan that's in there. So that was 1 centimeter from yesterday, and today it looks like it's more almost, I want to say just about 1.5 centimeters, 1.5 centimeters. And then just to check out how much it would be for the density of the thickness of it. So it's a little bit hard to measure on this. So that is just about 1.5 as well. So it's 1.5 for water density. And I'm just gonna put thickness on here. If we're gonna calculate the density of it, so it's just about 1.5. Okay, let's fish out the reason why the texture's like jelly-like is water, like mentioned earlier yesterday, that water is a great solvent, so it will expand and increase the semi-permeable membrane, which was represented by our gummy bears here. So that's why it became so huge as it is increased in size. So that's more like a hypotonic solution that with water, when we submerged the gummy bears into water, that was our hypotonic solution. And let's just fish out we still have salts in here, which is fine. But let me just fish out our gummy bears. So our gummy bear, it looks a little sad, it's tiny. So let's just compare for size. Size-wise is a lot smaller. Let's do the width of it. So the width is about just 0.5 centimeters. So we can label that, or when it's in salt, it's just 0.5. And the length of it decreases. So it is more like 1.5 centimeters. I would say an estimate of 1.5 centimeters, give or take. So that decreases by 0.5. And let's just see if we can measure the thickness of it, just to see. I'm not sure if my camera is gonna get this, but yep, it's about 0.5. And that just shows that the gummy bears were at equal parts and equal size. And this is for salt water. We're just gonna put salt water. And I'm sorry, I didn't have the density space for that. So I'm just gonna write this for the thickness of that. And it's just 0.5. So it decreases by 0.5. And the reason why it decreases by 0.5 is because salt water will draw out all the water from the gummy bear, making it into a hypertonic solution when it's in there. So let me see about our gummy bear that was in the vinegar. Let's see how that is. Well, it just looks like our gummy bear is getting really slimy. As you can see, I'm just draining out the water, and you can see that most of these molecules, as you can see, that's running down my glass here, is disintegrated because vinegar is acid. And as you can see, you can barely distinguish if it was a gummy bear or not. So this is going to be a little bit hard to measure, but we're going to do the best we can. So let's just start with, since we're this is why I didn't do the density from the get-go, is because of I use vinegar and it's kind of hard to measure the thickness of this. So we're just going to measure the width, but we're going to do our best to measure the thickness. So that is still, the width is still 1 for vinegar. And let's just see how wide the length is. So the length did increase by 2.5. So it's similar to water. So it increases by 0.5, I should say. So it's similar to water because you have to remember the vinegar will behave like water when it comes to semi-permeable membranes. But the only difference is that because it's vinegar, it's acidic, it'll break down the molecules of the glycogen, which is the gelatin-like material that we have here for our, it did increase for the thickness. It did increase, and I'm just gonna measure it like this because it's a lot easier, because I don't want the gelatin of our gummy bear to just be disintegrated. Okay, so it's about 1. So the thickness is about 1. that's vinegar. It's going to be about 1. So as you can see, osmosis is when the solution that it is submerged moves from low concentration to high concentration. And all these solutions here are the dependent variables, whereas our gummy bear is a dependent variable because it depends on what we put in the gummy bear in our solution. So, and as you can see, this is how vinegar works. It breaks down, and there's like little particles that you can see on the vinegar side that some of our gummy bears has been disintegrated and the molecules were broken down. And in our second experiment for just salt water has no broken samples of our gummy bear. It's intact, but it just shrinks it out because it draws out all the water molecules that was in the gummy bear. And with water, it just continued to expand in our gummy bears. And that was my fault. If you see a green thing, that was because I was trying to fish it out and I accidentally kind of chopped up our gummy bear. So I do apologize for that. But we can write on our observation that the change in our shape for our gummy berry expand tremendously. So, and you can see how chunky and fat and jelly-like it is. And then for our vinegar, it expands as well as it loses its shape. Sorry, my pen, I should have used a better pen. Loses the shape. Because of the vinegar, it breaks down. Vinegar is a natural state of breaking down molecules. And then for our salt water, it just draws out all the water molecules. So it'll have something that'll be hypertonic, which is going to shrink our gummy bears. So it's just going to shrink or shrivel, however you want to describe it. And that is pretty much what osmosis is. Okay, so we're going to graph this. If you're planning to graph it on Excel, you can input all the variables into Excel. So you're going to start off by putting in the first line. If you're putting it on Excel, you're going to label it as days. And then you're going to label it as the length for the second column going across. Third column would be the width. The first day the length was 2 for water. This is for water. And the width was 1. Second day, day 2, it's going to be the length went from 2 to 3.5, so it increased by 1.5, and then the width is about 1.5. So that kind of makes sense, right? Because it only increased that much. Because if you subtract that, you'll end up getting the original number for the length. And then vinegar, as you can see, it's all in here. So we'll do the same thing. But when you graph it, what's going to happen is you're going to only take the length and the width for it. And the gummy bear, your label's going to, let's draw like as if I was going to input all this information. You're going to put all this information, just how I have it here in this graph, to put for the graph, I should say, just all this information. You don't have to put the observation or anything like that, but you're going to put all of that, and you're just going to calculate. And then what we did here was we multiplied that, so that gave us 2, and we're going to multiply the second day, same thing, so on and so forth. So your X axis is going to be your dependent variable. That would be where your gummy bear is, okay? So your x-axis is going to be your gummy bear. Your y-axis will be your solution. And the reason why the y-axis is a solution, because it's an independent variable. The y-axis is where change occurs. This is where change occurs. So that is why it'll show, when you input it into Excel, it'll show it increases or decreases. Whereas for this graph here, I'm just demonstrating it. It's going to be for the second day. It'll be the gummy bear in day 2. Because that's where the change is. Because our day 1, nothing changed. All the size is going to be the same. Because it was only day 1 and we haven't seen anything happen to it. So we don't have to graph it, but it's best that you do graph it so you see a comparison of it. So let's just put that day 1 for water. Your graph should be looking like something like this. It increased that much. And I'll just put 1, 2, 3, 4. And then we're gonna put for vinegar. It did increase, but not so much like the water. And then the last one is salt water. That one didn't increase. Instead, it shrunk. So it became less than 2. It was like more like 1.5. And our highest increase was water, because water has a tendency to expand. And that's how your graph should look like, something similar to this for day 2. Day 1 graph will be a little bit different. So if I was to graph day 1, same thing, your x-axis right here going across will be our gummy bear. And we're gonna put water, vinegar, and salt water. And this is our y-axis. So we're just gonna label it as 1, 2. So I'll just put 1.5 here and then 2.5 here. And this is always gonna be, like I said before, it's always gonna be your independent variables. And this is when change happens. And this will stay, our x-axis is gonna be the same thing. This is the dependent. So whatever we put in is gonna make the change in the solution, such as water compared to vinegar, vinegar compared to salt water. So this is when it was all the same as our day 1. So this is day 1. So that's how our graph should look like. It's almost of equal size. And as you can see, that's basically from day 1 to day 2. And if you're gonna input this in Excel, you would calculate your calculation for area. For area, it's gonna be 2, and you're just gonna multiply the numbers that we got for day 2. So this will be like 5.25, And this was the one that I used for water. So you're gonna do the same thing because you're just gonna multiply these. That's how you're gonna get the area for that. Okay, and then you're gonna do the same thing for the other ones. So this would be 0.75 for salt water. That's how much it decreases. And then 2.5 is how much it increases. And in water, it's extreme, it increases extremely. So it's 0.25. And then in vinegar, it's just 2.5 that increase for the second day, and 0.75, which decreases for our salt. So you're gonna input, you don't have to use the 2 because that was for day 1. Remember, we're doing day 2. So day 2 variables should be something like, let me get it. Let's just use another one. So this is gonna be your X and Y axis, okay? So when you input it into this, so for water, for day 2, water is gonna be 5.25, and then vinegar is gonna be 2.5, and salt is gonna be 0.75. So that's salt water, vinegar. So you will put all these into Excel, and then this will be your y-axis. These are going to be your y-axis when you put into, and you're going to put your x-axis as day 2. That's what you're gonna do. And that is pretty much, this is an example of what my graph looks like that I did previously. So the blue represents the first day and the orange represents the second day, but I just put it as a series. And as you can see, these are the different solution, the causes of change, and then I put the title for it as well, where solution versus days and change of the gummy bear. So that's how your graph should look like once you input it into the system for Excel. It should look something like that. And if you don't know how to use Excel, you could just draw it. It should be fine as well, as long as you can see the differences on that. So next we're gonna go over the questions that I have for these. So for the first experiment that we did, we're just gonna go through these questions. So the first question asks, which experience did the gummy bear shrink in size and what causes it? That would be our second solution, which is salt and salt water, where the gummy bear shrink because salt will draw out the water. And that's going to create a shrink in shape, okay? And question number 2 is, on day 2, which experiment caused by the solution that makes the gummy bear slimy as it loses its shape? And that was our solution 3, which is vinegar solution. Because vinegar is an acid which breaks down the molecules and change the formation of the gummy bear. Third question asks, in what solution on day 2 made the gummy bear expand larger than day 1? That would be water, because water will expand the gummy bear. And that is due to osmosis, what our experiment is. It'll go from low concentration to high concentration to create an equilibrium. And the fourth question asks, from the second experiment, cup number 2, which is the vinegar, the pH of vinegar is usually under 7. So anything under 7 is actually acid, and vinegar is obviously an acid. And you can see that with our gummy bear where it breaks down. So you can look up for the pH on Google, but vinegar is an acid. And as we can see in our experiment, the formation of our gummy berry change because the molecule is broken down, and it also expands just like water. And this is basically what our experiment is. So hopefully you guys try it and learn what osmosis pathway does to our gummy bear. Have a great